All right, here's a video for the last 3 problems. This one here looks really complicated, but is actually one of the easier ones. Remember, you always want to try to simplify before you do any calculus. So let's just notice that there's this 2, if we need to, that's in there. And then try to feel what is that, right? What's sine squared plus cosine squared? And hopefully it's not too far of a stretch to say, hey, that's 1, right? That's that trig Pythagorean identity. So basically my position function is simply 2. Now if I want to find velocity, I have to take the derivative, right? So the derivative of 2 is 0. Right? So my velocity is always 0. And well, if I find the derivative of velocity to get to acceleration, then my acceleration, the derivative of 0 is 0. So my acceleration is always 0 as well. Right? So there you go. This one, if the position function is this s of t, find the intervals when it's speeding up and when it's slowing down. In order to do this, we first need to find the velocity, which is that, and then set the velocity equal to 0. Let's go ahead and factor out a 6 and divide both sides by 6 at the same time. And we get that, and we're trying to factor that. And then before I said it was t minus 1 and t plus 1, but it's definitely not that. You can't factor that way. And so if you can't factor it, then you're left with maybe quadratic formula, which is not bad to remember just because it does pop up every once in a while. So negative b, which is going to be negative 2, which is that, plus or minus square root of b squared, which is going to be 4 minus 4ac, all over 2 times a, which is going to give me 2 plus or minus negative 4 over 2, which right here, this says there's a negative square root here, which means there's no real solutions. There's only imaginary solutions. So this means that the velocity is never 0. This thing never stops. It never changes directions. Right? So all we really need to figure out is it going up or going down, right? Is this thing increasing or decreasing? So just plug in a number, right? Plug in even 0 is fine, right? Plug in 0 and you're going to get positive, right? So v of 0 is positive. So the particle, so the object, because I only say particle, is always moving forward. We do need to check the acceleration, so let's get the acceleration function, and acceleration is going to be derivative velocity, which will be 12t minus 12. So basically, when is the acceleration equal to 0 is when t equals 1. So I need to check 1. If I plug in a number left of 1, I get 0 minus 12, which is negative. Right of 1 will give me positive. So what that means is the velocity is always positive. Right? Velocity is always positive. Therefore, between anything left of 1, the signs are different, right? Because acceleration is negative and velocity is positive. So anything left of 1, so when t is less than 1, the signs are different and it's slowing down. And anything right of 1, greater than 1, the velocity is always positive, and at that point the acceleration is positive. Well, so it would be speeding up. right? Last one, we want to estimate the acceleration at t equals 6. So to estimate the acceleration, we're going to use the average acceleration, which means we're going to find the average between the points that are closest to 6. So basically, we're going to say v of 8 minus v of 4 over 8 minus 4, right? This is going to be the average acceleration. And this is 10 minus 16 over 4, which is negative 6 over 4, which is negative 3 halves, which is that guy right there. All right, I hope this is helpful.